Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be talking about deriving and integrating power series. So again, we're going to take series that we actually have a general term or specific terms for, okay, and derive and integrate them. We're going to talk about how we're going to go about doing that. All right? All right, so let's get started. So again, in the last video, we know that our ability to write a function in the form 1 over 1 minus x unlocks our ability to turn that function into a series, right? We did that. Okay, so if we had this geometric series in the last video, the sum a times r to the n, and we knew the sum of that was a over 1 minus r. Okay, if a is 1 and r is x, then that would give me 1 over 1 minus x, which then I could write in this series form 1 times x to the n. Okay, and that would be my series, n equals 0 to infinity. All right, so that would be my series there. Okay, but what if I have a series, or I want a series for a function such as 1 over 1 minus x squared? Well, it's not as simple as just squaring the denominator, because when you square the denominator, you create extra terms, right? Okay, you'd have to multiply it out, and you'd end up with extra terms in there that you didn't have a minute ago. So it's really not something you can write in this form. But here's the thing. If I had the function f of x is 1 over 1 minus x, and I wrote it as 1 minus x to the negative 1, and I found its derivative, that would give me negative 1 minus x to the negative 2 times negative 1, right, with the chain rule. So that would give me f prime of x is 1 over 1 minus x squared. So then, well, wait a minute. If I know that there's a series for this called x to the n, and I want a series for g of x, well, the series for f of x is x to the n. How could I take this series, x to the n, and write the series for 1 over 1 minus x squared? Well, if I derive 1 over 1 minus x, I get 1 over 1 minus x squared. So then theoretically, if I derive this series, I should be able to get the series for that derivative, right? So if I derive this series somehow, it should give me a representation in series form for this function. So this video is about how do we do that? Okay, how are we allowed to derive and integrate series? So let's talk about derivatives first. So suppose a power series has a radius of convergence r, and this is the series. C is its center, and these are all the terms if I start writing them out, right? If I substitute 0 in and put a 0 power here, that gives me a 1 for that. So that would be a0. If I put 1 in, a1 times x minus c to the first, a2, x minus c squared, and we can keep going forever because we're going to infinity. Okay, suppose this power series has some radius of convergence called r, and this is the function that it represents. Then the derivative of f of x would be the derivative of this series, which means that it's the derivative of each one of these terms, an infinite number of them, but it would be the derivative of each. So the derivative of a0, a is a number, is 0. The derivative of a1 x minus c would be a1. The derivative of a2 x minus c squared, well, leave the a2. This would be a power rule problem. Bring the 2 down, leave the x minus 2 or x minus c, and put the power to the first, right? And then the same thing here. Leave the a3, bring the 3 down, take 1 from the power, and we can do this forever. So then how does this work? Basically what we're doing is the derivative then, we can also find the derivative of the actual general term of the series, x is the variable. It's f prime of x, the derivative with respect to x. So I would bring the n down, leave a n, bring the n down as a power rule problem, leave the x minus c, and take one from the power. This is the derivative of this function. Okay? Now, more importantly, this series will also have the same radius of convergence of r that this function f had. That's the radius of convergence, r for f. R will be the same radius of convergence for the derivative. But the endpoints are up for renegotiation. So the endpoints in the interval of convergence have to be retested in the derivative series to determine whether or not they converge or diverge. Okay? Only the radius of convergence is guaranteed to be the same. All right? The interval of convergence will be the same up to potentially the endpoints could be different. So they have to be retested. Okay? So, for example, on our last slide, we said f of x is equal to the sum of x to the n, which was 1 over 1 minus x. And then we said that f prime of x is really 1 over 1 minus x quantity squared. Well, then the series for that will be the sum. What's the derivative of x to the n? N x to the n minus 1. That's the series for that function. Okay, you can derive series just as you derive functions. And that's what's important here. All right, now let's talk about integrals. Suppose the power series again has this radius of convergence r. Then what would the integral of f of x look like? Well, the integral of f of x, what would this be if I were to integrate this thing in general? The integral of f of x dx would be the integral of the sum of a sub n x minus c to the n with respect to x. Well, x is the variable, right? The rules apply to x's. A sub n is a constant. So this would be the sum of a sub n x minus c to the n plus 1 over n plus 1. Now, technically, there's a plus c here as well. It's a little confusing. C is the center, right? And then plus c is the constant of integration. Okay, but a lot of times you can knock this constant of integration out depending on what you pick for the initial condition. All right? So we can also integrate general terms for the series. Again, this series will also have a radius of convergence of r, the same as f, but the endpoints would have to be retested. Okay? All right, so let's see how this works. Let's write the first three non-zero terms and the general term for f of x equals sine x. So we're going to do this as a Maclaurin series, okay, where c is equal to 0. All right, we're going to write the first three non-zero terms in the general term. So if we were to do that, m sub 3 of x would be, let's see, we'd start with f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x squared plus f triple prime of 0 over 3 factorial x cubed. Okay, so f of 0 is sine 0. That's 0. F prime is cosine x. So f prime of 0 is 1. F double prime is negative sine x. So that's going to be 0 again. F triple prime is negative cosine x. That's going to be negative 1. All right, so let's write the Maclaurin polynomial, and then we'll determine what the general term is. So we have 0 for f of 0. F prime of 0 is 1x. F double prime of 0 is 0, so this is going to be a 0 again. Then this one's going to be minus 1 over 3 factorial x cubed plus now. So that would be the first three non-zero terms. Oh, no, not the first three. That's only the first two non-zero terms. We have to keep going. So the fourth derivative is going to be sine x. Again, that's going to give me a 0. The fifth derivative is going to be cosine x. That's going to give me 1. So that's going to be the fifth derivative at 0, which is 1 over 5 factorial x to the fifth. Okay, there's the first three non-zero terms. Now, the general term, you can see what's happening. we're doing only the odd powers, right? So x to the first, x to the third, x to the fifth, they're all in the game. All the even powers are out because the derivative of sine, the first time you find the derivative, gives you cosine. So it knocks out, or it keeps in the odd powers, right? The odd derivatives. But then f double prime will be back to sine again. That'll be 0. The fourth derivative is back to sine again. That's again 0 when you put 0 in. So the general term then is going to be x to the, well, negative 1 to the n. It alternates, right? Negative 1 to the n. And then we're going to have x to the 2n plus 1 over 2n plus 1 factorial. We agree? Yep, I think that'll do it. Okay, so there's my general term for f of x equals sine x. All right, now, what's the first two terms in the general term for f prime of x? Well, what's the derivative of this? So f prime of x, well, the derivative of x is 1. The derivative of negative x cubed over 3 factorial is negative 3x squared over 3 factorial, which we can clean up in a minute. The derivative of x to the fifth over 5 factorial is 5x to the fourth over 5 factorial. And then the derivative of that, remember the rules apply to x's only. These two are constants, right? They're just numbers. Leave the negative 1 to the end there. Derivative of x to the 2n minus 1. It's a power rule problem. 2n plus 1 times x to the, I'm going to have to erase some stuff here. Let me erase this here, get this out of there. It's going to give me x to the 2n plus 1 minus 1 all over 2n plus 1 factorial. Okay, so that's going to be 1 minus, I can drop the 3 out of 3 factorial. It'll give me x squared over 2 factorial now. 5 out of 5 factorial will give me 4 factorial underneath, x to the fourth up top, minus, plus, negative 1 to the n, 2n plus 1 drops out of the 2n plus 1 factorial, gives me 2n factorial, and then 2n plus 1 minus 1 is x to the 2n. That is the first two terms they wanted. All right, well, I gave them 3. And the general term for f prime of x. Okay? All right. So again, we're using the Maclaurin polynomial to come up with the original terms and then a general term, and then we're able to find its derivative to give us the derivative of that. Now, the idea here is that, well, if f of x is equal to sine, the derivative of sine is cosine. So theoretically, that series or that set of terms should have something to do with cosine x. And that's coming up in a future video, but spoiler alert, it does. This is the series for cosine x. Okay? All right. So let's try this one. Suppose g of x is equal to this sum. What are the first 3 terms in the general term for g prime? All right, well, let's write the first 3 terms for g. We know the general term here. First 3 terms for g. If I substitute 1 in, I get x over 1. Next term, plug in 2, x squared over 2. The next one is x cubed over 3. And then the general term is x to the n over n. For g prime, I'm going to have to derive this. Derivative of x is 1. Derivative of x squared over 2 is 2x over 2. Then 3x squared over 3. And then n x to the n minus 1 over n. So that's 1 plus x squared plus x to the n minus 1. That are the first 3 terms and the general term for the derivative of this series g. Okay? So hopefully we're getting the hang of this. All right, finally, let's suppose that h of x is equal to this. Here's 3 terms of it and then the general term for it. Let's write the first 3 terms in the general term for h prime. Okay, h prime means I'm going to derive each one of these terms. So that's negative 1/2 plus 4x over 3 minus 9x squared over 4. Leave the negative 1 to the n over n plus 1 out of it. And the derivative of x to the n is nx to the n minus 1. And that would be my answer. So now, I want the first three terms in the general term for the integral from 1 to x of h of t dt. So I'm going back to h again. Just be careful. We're not using h prime. We're using h again. We're going back there. All right, so now I want to integrate from 1 to x. I'm going to replace all the x's with t's. That's what they're asking me to do here. 2t squared over 3 minus 3t to the fourth. 3t cubed over 4 plus negative 1 to the n, t to the n over n plus 1 dt. Okay, so now I want to integrate this with respect to t. So this would be straight line from 1 to x. Here we go. We'd have negative, add 1 to the power, divide by what you get. T squared over 4 plus 2t cubed over 9 minus 3t to the fourth over 16. Negative 1 to the n, t to the n plus 1 over n plus 1 squared. So now I'm going to evaluate this from 1 to x, which means I'm going to substitute 1 in, and then I'm going to substitute x in first, then I'm going to substitute 1 in. So that would give me negative x squared over 4 plus 2x cubed over 9 minus 3x to the fourth over 16. And the general term would be negative 1 to the n, x to the n plus 1 over n plus 1 squared minus, then I'm going to substitute 1 in. So that's negative 1/4 plus 2/9 minus 3/16 plus negative 1 to the n. That's going to be 1. That's going to be 1. 1 to the n plus 1 is 1 over n plus 1 squared. And that's the idea. That's what you should be able to do. So for example, you should be able to understand the fact that you can take this function h of x, right, and integrate each one of these terms and the general term and then substitute values in using that fundamental theorem of calculus. Okay? So that's the biggest thing here. The idea that a series can be derived and it can be integrated, including the individual terms of that series. All right? And that's it. As always, thanks for clicking.